using machine learning in R. The easiest way to start a no code in data science and machine learning is using a package called Rattle. Rattle is based in R, so you need to install R. That is the platform. R Studio is the GUI. You need to run few lines of code. You need to basically install RGK, RGTK2 and Rattle. This both the lines of codes. I'll put it on the description as well. So this is the thing we need to run, and we need to call Rattle. When you do this, there are a lot of dependencies that get loaded in, and we need to just be patient and wait for a time, then something like this will open up. So this is a R data miner called Rattle. So now what we have is we have a simple you can say sales data that is there, which I will just open here for you and explain you the data. It is about a retail store data about the items that are there and what is getting sold. We What are the items that are getting sold? We need to understand which are the more items that are getting sold, and how we can analyze the sales performance of the data and understand which are the categories, which are the items that are getting sold more, so that we can incorporate it in our uh, next quarter more in that type of product. So this is a simple data with identifier, item weight, item fat, item visibility, item MRP, the price that you are paying for that, the outlet identifier, the outlet when it was established, whether it is an old outlet or a new outlet, the size of the outlet, whether it is a big outlet or not a big outlet, and where is the outlet, which location type the outlet it, and what is the type of the outlet, whether it is a supermarket and grocery. Something that is a little bit and to understand here is the item visibility in the shelf that is there, how visible the items are there according to the planogram. So these are the basic things that are there. It's a simple table for us to just quickly see how Rattle works with 11 number of variables, number 11 columns that are there, and we have 5682 with one being the row header, so 5681 rows of data that we have. So now this is the simple data set that we have. This will also be available for you to download and to practice. And this particular thing is a simple data. We know how to call it. So if you want me to do it in front of you again, just to show this, I will just close this off. This is my R Studio. I will just do again Rattle, and now this has opened. So this has opened. So you can just do this. Now we have a completely new screen in front of us. This is a GUI. There is no data that is there. So now first we need to get the data, and the data I have stored it on the desktop. Sales data, the same data that I showed you. We know that it is a comma separated file, so the comma is here. Now the decimal, as we all know that there is a decimal as in numbers are there, and the first row is a header. What is the source of this? There are a lot of options that are there. I have given the source as a simple file. This is the GUI of Rattle R data miner. It is very simple. It has an execute, new, open, save. It has a different steps of our machine learning modeling piece, that is data, explore, test, transform, cluster, associate, model, evaluate, and log. So these are the different tabs. We will look at one each of these in details in our later uh, videos. And then what we are doing is we are first uploading the file name. As I showed you, we have a partition. So what is basically a partition is, as we all know, I have talked about in the previous videos as well, we have to train our model in a particular set, that is the 70%. We need to test whether our model that we have built, is it giving a good accuracy that can be used, that is the Another 15%, and the other 15 is we are validating our output, that the what model we have trained and tested, are they also working on the validation data. So these three things are very important, and we keep the split that is there. Random is something that from where the initialization starts for any of our analysis. We can put it any number, it starts from 40, you can put any number that you want. So I will, that does not matter, but it has to be the same when you are doing all the analysis. So now I put it as 35, and it is going to be stuck at 35. Now what we are going to do is we are going to first click execute to get the data on board. So we click execute, and then we can see our data is uploaded in the our data miner platform, Rattle platform. We have all the data types that are there, the name of the variables. As I told you, there are 11 variables. We have the data types that are there. So categorical means it is a it is something called category, character level, and numeric is number level, wherein there are numbers that are there. And then there is one thing that is input and target. As you can see, there is a something called input and a target here. Let me just get an option of, okay, so this is the thing that is there. As we all know, the target here is our MR. We want to know which are the items that are getting sold. So we will put the target as a item MRP, because we want to know what are the items that are sold and what is the sales that is happening. And we will put everything else as numeric. As I told you, categorical are items that have uh, characters, and they are like I've used for grouping. One thing that, as you can see, is there is unique level of identifier is 1543. So this does not make any help for us, so that we can ignore this particular thing. And also outlet size, okay, there are a lot of ones that are missing, but for now we will keep it. But we don't need actually item identifier. Weights we will keep blank. Risk as of now we'll keep blank. Ident will keep blank for now. In comments you will see what are the unique number of items that are there, like unique non duplicated items that are there. Missing will give us the number of missing or NAs in that particular data set. So this is the this particular thing is the details about this complete picture about this data. So now we have already done this. Now we will just go to explore, and we will just do a small summary and see about the data. We have just clicked summary. We will not change anything. We will do a summary. It appears that there have been changes made. So actually I have seen I made some changes, right? I made some changes here and here. So what I need to do is I need to again click execute to make sure that whatever changes that I have done is being replicated on the data model. And now I will go to explore, and then I will do a summary. Then again I will do an execute. So we all know whatever we have done, very simplified way. It is showing us the number of items, the number of variables that we have, what are the levels with how many unique items that are there at each for that particular category. As we remember, we ignored item identifier, so that is not here. The rest of the things are here. The storage double and integer is just the way it is getting stored. And NAs are the number of NAs. As we see, 635 NAs in the item weight, and in the outlet size 1131 NAs. So for now we will leave the NAs as such, and we will go ahead and understand the different levels that are there. So the variables and the levels are detailed, they are given here, as you can see. So one thing that we have to understand is we need to do a lot of cleaning here, but right now this particular thing is no code, so we are just trying to explain you how we can build a quick machine learning using Rattle. So atom fact, content, item type, outlet identifier, outlet size, outlet location type, and outlet type. Everything is given here, the different levels. And now we'll come to the interesting part about the numerical and categorical summary. So here numerical summary is basically minimum, first quartile, median, mean, and third quartile. So this is a way in which when we are telling that for a item weight, it starts from 4.55 and it goes up to a maximum of 21.35. I have talked about the mean, median, mode, quartiles much more in my statistical course that I have done, the basic statistical courses that I have done. And this is the way it is just giving us an idea about the distribution of the data. For numerical, it is in the way of distribution. For categorical, it is levels. Every level, as you can see in item fat content, every 5 levels, what is the distribution of items that are there. As we can see, regular has maximum of 1357. So this is the way in which we can do a quick summary of the data. And then quickly one by one, if we can remove the summary and then do a describe and see everything again and again in more detail. As we can see, the same thing that we are doing in a much more detailed way that is there. It is giving you a complete mean, median, and a complete percentile that is there for the data. Now, as you can see, there is a GMD here. So if what I can do is I can now try to explain you GMD using the power of ChatGPT as well. How to explain this in simple English, right? GMD, what is the GMD of 5.7 for item 8? Explain in English. So this is going to tell us, let it respond, I'm sure. Uh, GMT is a geometric mean distance, but we need to explain you. And one more thing you can notice is 3976 observation. As you said, the total rose by 5681. In that, we are only doing analysis for the 17%. So this is taking some time. Let me do a new chat. As you all know, it is a little bit slow. Hmm. I refer based on context, it refers to JMD. See, it is see the way. So this is how you have to learn, understand, and learn. This is why I am showing you Chat GPT, and many people of will say that see, these are small statistical concepts that are there, which you will to explain in English. This is a very good way, because mathematically, if I tell you, you will not remember. So in mathematics, what happens? This is a measure of central tendency that is calculated taking the product of a set of numbers and taking the nth root. This formula and all you don't need to remember. It is basically this particular thing you have to understand. A GMD of 5.7 and item weight likely means that the geometric mean diameter of the components of the item is calculated to be 5.7 based on a specific measure or analysis method, and this value provides an indication of average size in this particular item. So it is a way of calculation. It is basically is commonly used in the field such as particle size analysis, where it provides a representative value for average size of a particle in a sample. It takes into account both large and small, and it often characterizes the size distribution of the particles in a granular material. So basically, this is a way of calculating the geometric mean according to some logic about the size of the sample, the distribution of the large and the small ones, and it is giving us an output. So as we can see here, the mean is for item weight is 12.74, but most of that particular items are in the 5.34 range. So this is something you can say according to some statistical technique. It is telling us something like that. So we need to understand that particular thing. And here we have 5 percentile, 10 percentile, 8 percentile, 50, 75, and 20 percentile that is there. So now we have to understand the categorical. In categorical, they are mainly giving the frequency and the proportion. The one that I had don't told about the fat content, we will see again. uh, uh, the regular is 34%, and the low fat is the maximum, that is 59%. So this is the distribution of the frequency of the items that are there in the particular cell. Now what we have to do is, we have to see there are some different tests that are there, that is important. So you need to see what all tests that you want to do accordingly. So here I don't want to do any test as such. I want to do correlation. So in correlation, what I am going to do is, here only before doing any going to test, we need to first finish all these things that are there. So now let us see some basic. What is the thing about the basic that is there? It is running some packages. So whenever it allows you to ask for to run any package, please do that. So it is going to make some graphs in R. Okay. So basic, the same thing for every variable item weight. It is going to give you the number of observation missing, the mean, this thing, the standard mean, the confidence level, upper lower variance, standard deviation, skewness, and kurtosis. So standard deviation is, mean is basically, mean is 12. A mean is approximately, we all know it is 12. So and standard deviation is 4. So it means that, uh, minus, 12 minus 4 will be 8 weight 8 grams to 16 grams, 68 percentage of the items are there. So the tendency is likely to be there. Similarly for the other things that are there, uh, I just made a Jamboard for which I will just show here. Yes, so in this case, as you can see, when we say that the mean is 12, what happens is, yes, so from the mean, this side and this side, so minus whatever is the mean, 4.5. So 8 grams, yeah, 7 grams to 17 grams, in that 68% of our population is there. So that is the meaning of standard deviation, which you just need to know the basics just to understand and to explore. So now we do this for everything, for all the numerical variables that you can see. We have done this basic thing that is there. Now there are other things, kurtosis and skewness is basically when you are distributing the points. If this particular central tendency, if it is skewing towards right or skewing towards left, and what is the distribution of the items that are there. uh, for that we need to understand this particular thing, that there is some calculations to understand that, but in English it is just telling us whether it is centrally aligned. So here this particular, if it's a normal distribution, then the skewness is actually 0, because it is normally distributed, it is not skewed to the right or left. And also kurtosis is telling you how much that width, like how much the width is here. If this is the kurtosis is very high. If it is like this, then the basically the difference between the base and the height of the graph, if it is less, then it is more of, you can say, the kurtosis is there less. So you need to, these are the some of the ways of telling about the distribution of the data, and basic exploration you can need to have a look at more and more. Now crosstab, let us see what crosstab does. Crosstab is basically, now it is showing between two different items, what is the value. But here, as we know, it is too much numerical values are there, so it will not going to give a correct output. So it is going to get stuck. So now we have to wait. Ideally we should not do this. And so this is a basic summary that is there. In the next video we will understand more about what model we have to build, and why we have to build, this particular thing, and see you in the next video. Thank you.